to whoever's watching this video on the first lesson of the electromagnetism scheme. This one's on magnets, and I tend to start with magnets because that's something that children tend to be familiar with from primary school. It's something that they've seen lots of before. They're quite happy with this idea that you get attraction and repulsion with magnets, and I think it's a good way to it's a good place to start before you then go on to talk about charge and the attraction and repulsion of charges, which obviously work in an analogous way. Now, when you're teaching this lesson, I think you can get straight into it, and I'm at home. I don't have magnets and stuff here. I don't have a prep room at home, unfortunately. But you will know what to do, and you can show students the different materials and how, and maybe they can do this themselves, find out how some of them are magnetic, some of them aren't magnetic, and so on. And what we'll see later is some examples where you get them to think about some of that stuff. So much of this will be familiar, but really I think the main point of this video is to show you how you can get them thinking in terms of the information that you're going to give them. Now, when you model, I'm sure you will have done this before, bringing magnets together and showing how some will repel and some will be attracted, and again, they will be familiar with this. That will be nothing new to them. I think you can draw a quick diagram just to show it, that when magnets are brought together you get something like this. So if I was to do that under the visualizer, I would just do something along these lines and say, well, if I had two magnets like that, and I'm going to draw three cases of these. So let's draw three like that. And this is when you're bringing two bar magnets together. And again, I would only draw this after I'd demonstrated it with real magnets. But all you'd want to do here is just say, well, let's take the first case. If I had S and N, and let's say N and S, and then show them what would happen, well, they would move apart. Now, this comes after the forces unit in the curriculum, so they should be fairly familiar. I mean, I'm going to draw it from there. Really, though, it should go from the center of mass, although it's not the end of the world if it doesn't, but let's keep it consistent. So I would show that there's going to be a force that way, and I'd make sure that they're happy using that word repel. So rather than push apart or something like that, you need to be comfortable with that language. Oh, sorry, I've smudged there. Next, I would have another case. So let's say I've got south and north, and then south and north. Well, hopefully they would know anyway, but you can reinforce this, that these two would attract, beg your pardon. So they would be brought towards one another like that, and you can make sure to use that word, so, action, and then you could do the same sort of diagram for this one. So let's do NS, S, N, and just show those diagrams like this. So I'll do this quite quickly. We're going to have repulsion again, so this is going to look a bit like this. So rather than just giving them the straight up kind of general rule, likes repel, opposites attract, I think it's worth spelling it out and going through and just writing that, getting them to note that down into their book, so that when they're then thinking about it and they're asked a question in the deliberate practice, which says something along the lines of, how do you make magnets attract and repel one another? Well, then they can use these diagrams to tell you. Now, where it gets interesting in this lesson is the further questions at the end, and there's two really nice questions, and if you wanted to do more practice on this, you could come up with more similar ones, like further similar ones, but they look a bit like this. Now, I wouldn't draw these out in class. I would just print it out and work under the visualizer with the printout. But what we've got here is, in the question, this is the first of the examples, and I think once you've been through the kind of basic comprehension questions, these are really good ones to think about, and you can model this with your student and then get them to practice one or more. But we've got this example where you've got three rods, A, B, and C, and you know that one of them is made of iron, one of them is made of copper, and one of them is a magnet. And the question is, well, which one's which? And you're given a little bit of information. So you've given this first one, that if A is brought near to the north or the south pole, the magnet attracts it. If B is brought near the north pole, nothing happens, and you've got to work out what's going to happen if it's brought near the south pole. And then with C, if it's brought near the north pole, it attracts, and you've got to work out what happens if it's brought near the south pole. And then from that, you've got to work out which material or which rod is which, the copper, the iron, or the magnet. So the first thing that you can point out, and this is nice because it's getting students to apply knowledge, it's thinking in terms of the concept rather than just repeating back the fact that you've just given them. So one of the things that comes up earlier that's worth emphasizing when you're doing your modeling, and this is or demonstrating, I should say, this is in the deliberate practice. There is a question on this. One of the things that students need to know is that the force between a magnet and a magnetic material is always attractive. So in this case, if you turn it either way and you get an attractive force, well, this must be a magnetic material. It's not a magnet, it's a magnetic material. So in that case, we can work out straight away that this one must be iron, because copper is not a magnetic material, and hopefully by this point they know it, and that's the kind of thing we can model. If B, nothing happens, well, we know it's either copper, which is a non-magnetic material, or it's a magnet. But if, and again, this is where it's a nice chance to model some of the if-then kind of deductive thinking, which really makes science distinct. We can say, well, okay, if I brought a magnet near there, would nothing happen? Well, no, it wouldn't. It would either attract or repel, because I know that about magnets already. So it can't be a magnet, so this must be copper. But then if I brought it near the south pole, what would you expect to happen? Would it attract? Would it repel? Would nothing happen? Well, again, this would be nothing happens, okay? Because non-magnetic materials don't interact with magnets at all. So then the last one, we kind of know from process of elimination that iron, copper, well, there's one left and that must be the magnet, so this must be the magnet. Oops, magnet. And then we can say, well, okay, if I bring the magnet, and this is the kind of thing, again, you can model, if I bring the magnet close to another magnet and it attracts, well, that tells me this must be the south pole, this must be the north pole, because opposites attract. So if I assume that I've not moved the rod, then I bring the south pole near, well, then I'm going to have two lights. What do lights do? They repel, and therefore this can be repels. Now, I've raced through that because I don't want this video to be too long, but you can spend a bit longer on that, and I think really modeling that sort of thought process and maybe doing it with some real examples, that is a really, really powerful way, not just to give students the information, but to get them thinking in terms of these concepts to do with attraction and repulsion of poles. In the next video, we'll be looking at magnetic fields, and that's a new concept.